I need to get me some new stickers.
I love the stickers.
Ethan, you're in such a peppy mood today.
All right. Okay. All right. Last section. Volume with the washer method revolving around axes that are not the x or the y axis in the frozen. Oops. All right. So really, there's not much new that I need to teach you about the situation because you kind of learned all of the pieces. It's just today we're not revolving around the x or the y-axis. We'll be revolving around horizontal or vertical lines other than those. So in this case, when we're doing that capital R of x and that lowercase r of x, that second number is not always going to be 0 in this case. In fact, sometimes the first number is like 3 minus the equation. It just depends on what the graph looks like. So graphs are really important on these. And 1 does not give us a graph, so we need to come up with one. We've got the region bounded by x equals 0, square root of x, and y equals 1. When revolved about the horizontal line, y equals 1. So x equals 0 is the y-axis. We've got y equals square root of x, and we've got y equals 1. So we don't need, this is going to be first quadrant stuff right here because really square root of x only exists in the first quadrant anyway. And we've got x equals 0. Here is just the y-axis. We've got y equals 1 would be just a horizontal line right here at y equals 1. And then the graph of y equals square root of x. Square root of 0 is 0. Let me label this 1. Square root of 1 is 1. And so the square root function, let's draw it. It's like concave down. Looks like this here. So we are talking about this area right here. And we are rotating around y equals 1. Now, this one actually is not a washer method for this. I think that was supposed to say disc and washer. This is not a washer method because we are rotating around this line right here. So in this case, our capital R of x, we touch this line the whole time, right? Our area is touching the line that we're rotating around. This graph, whenever we spin it around, is not going to have a hole through the middle. So in this one, we don't really need a lowercase r of x, or if you do, it's got to be 0, right? So when you're finding capital R of x, you want to think about going from the line that you're rotating around, which is this green line right here, to the outside of the area. Okay, that is your capital R of x. And in this case, you do not have a lowercase r of x because there's no hole in the graph. You touch that line that you're rotating around the whole time. So capital R of x is going to be top of that line, which is going to be 1, minus the bottom of that line, which is the square root of x. Are we okay there? Okay, so in this case, we're going to have pi times the radius, which is 1 minus square root of x, squared. We are going to integrate that. What do the limits need to be? 0 to 1. Which axis are we looking at? X-axis, because y-axis is also 0 to 1 here, but we're looking at the x-axis for that. So this one It's not too terrible. We're going to do this one by hand, and then we'll probably won't for some of the others. We've got to square this out before we integrate. So we're doing 1 minus the square root of x times 1 minus the square root of x. You can square, double square, or you can write it out like this. You're going to get 1 minus square root of x minus square root of x plus just x, because square root of x times square root of x is just x. And this is going to be 1 minus 2 square root of x plus x. I'm going to use fractional exponents instead of that square root. So I'm going to have 1 minus 2x to the 1/2 plus x. So when, limits are 0 to 1. When we integrate, actually I don't need my integral symbol anymore because I'm getting ready to integrate. We will have just x right here. Then we got x to the 3/2. And then I've got to do 2 divided by 3/2. Dividing fractions is easy as pie. Flip the second and multiply. I'm going to get 4/3. So minus 4/3 x to the 3/2 plus 1/2 x squared. Everybody okay here? Fortunately, the numbers you're plugging in are 0 and 1, so that's going to be pretty easy to do here. So you will get 1 minus 4/3 1 times 1 to 3/2 plus 1/2 times 1 squared. What are you going to get when you plug 0 into that stuff? It's going to be 0. I'm going to just put a 0 right here. Don't always assume that's going to be the case, but if you plug in a 0 here, a 0 here, and a 0 here, all your terms are 0. If you have something like cosine or logs or something like that, be careful with it. It's not always 0. But we're going to get pi times 1 minus 4/3 plus 1/2. And we're going to get common denominators for that. So 6/6 minus 8/6 plus 3/6 is going to give us 1/6. So we will get pi times 1/6, which they will probably give us as pi/6. Okay, questions? All right, let's try another one. Okay, this one, we've got region R. It's bounded by y equals x, y equals 3, x equals 0, and we're finding the volume of the solid created by rotating, this should say the region R about the line y equals 4. So we've got all straight lines here. It's pretty easy to graph, but we're rotating around y equals 4. So it's going to be a little bit different than what we've seen on the others. So y equals x is just a line with a slope of 1 and a y-intercept at 0. We get this beautiful line right here. Y equals 3 is a horizontal line at 3. X equals 0 is the y-axis right here. So our region that we're going to have is going to be this right here. Now, if we were rotating around the line y equals 3, this would just be a cone. It wouldn't even necessarily be something you had to have a integral for. But what are we rotating around? Y equals 4. So we are rotating around this line up here. This is our line that we are rotating around. So this is going to have a hole in the middle because there's space between your region and the line that you're rotating around. So you're going to have a capital R and a lowercase r for this. So in this case, when we're doing our capital R, you want to start at the line you're rotating around. Make sure it's not X or Y axis in this case. Line you're rotating around, go out to the furthest point on the region that you're looking at. That is your capital R of X. And so when I'm writing my equation for capital R of X, I want to think about what function my R of X hits at the top. What would that one be? It's 4 minus what we're hitting at the bottom. What do we hit at the bottom? Y equals X, so just X. So it's 4 minus X for capital R of X. For lowercase r of X, I'm out of colors to use here. How about this one? For lowercase r of X, I'm going from the line I'm rotating around, always start there, to the closest point on your highlighted region. So this is your lowercase r of X. And so lowercase r of X is going to be what we hit at the top. What are we hitting at the top? 4. Minus what we're hitting at the bottom. What are we hitting at the bottom? 3. And so in this case, it's just 1. That radius is going to be the same. It's just a cylinder that's like getting cut out of this middle part. So we get a number. That doesn't always happen. Sometimes it will have a function there as well. So if we're setting this up, you can set it up separately. You can set it up as integrals together. I'm going to do both so you can see what it looks like both ways. You could do pi times 4 minus x squared, integrated from, what are our limits here? Not 0 to 4. 0 to 3. It comes from your x-axis, so it's right here at 0, over here to 3 for that. So that would be like our outside minus our inside, so still from 0 to 3, pi times 1 squared, split the x's with this. However, a lot of times you'll see this, especially if it's a setup problem and it's multiple choice, a lot of times you'll see it all as one integral. So if they do that, the pi will be pulled out front. You'll have your 0 to 3, and it will be your capital R squared, so 4 minus x squared, minus lowercase r squared, which is just 1 squared, dx. If you have to solve it by hand, that second version is the easier version to deal with because you would only have to plug in one time instead of into 2 separate functions. Here, I don't think I want to take the time to work that out. You would square everything out. You would integrate. You're going to get some fractions. You got to plug in a 3. It's not terribly difficult. I think it's just a little more than they're going to actually give you on the exam. So if we just integrate with the calculator, integral 0 to 3 of 4 minus x squared minus 1. Obviously, this 1 squared is not really necessary. I could change it to just a 1 there and dx. And so we're getting 56.549. Okay, we're right here. All right. Hopefully I made this last one around a vertical line. Yes. Okay, so this last one, the region in the first quadrant is bounded by y equals 2 minus x, y equals 2 minus 2x, and this is revolved around the line x equals 3 to create a solid, find the volume of this solid. So for this, I need to graph both of these lines, and it is first quadrant. So since it's first quadrant, I know that like my x-axis, and y-axis here are also boundaries, since they told us we're only doing first quadrant. So I have got, I'm going to do this one in blue, y equals 2 minus x. What's the y-intercept of that line? Is 2. What's the slope? Negative 1. Down 1, right 1, down 1, right 1. Like so. So I'd get this line right here. And then I've got y equals 2 minus 2x. I don't know why I zoomed this way on this graph. It's not the easiest to see. I should have zoomed in more and not included all this negative part on the bottom. I don't know what I was doing. So I'm going to have y equals 2 minus 2x. So y-intercept at 2. What's my slope here? Negative 2. So I go down 2, right 1. So down 2, right 1. That gives me this. So, like I said, I should have made the scale on that graph different so that it was bigger and we could see it. But we're looking at this area right here. That is going to be what falls in that first quadrant between those two functions. Getting a graph right for these is so important. So if you don't have a graph, that's the first thing that you want to do. And so we're revolving this around the line x equals 3. So x equals 3 is a vertical line here. So I'll use x equals 3. That is this vertical line right here. Okay. So if I'm, first of all, if I'm revolving around a vertical line, everything has to be in terms of y, right? So I need to take y equals 2 minus x, and I need to solve it for x instead. So I would need to subtract 2, y minus 2 will equal negative x, and then I need to divide everything by negative 1. So I got negative y plus 2 equals x. So this graph right here, x equals negative y plus 2. And then I want to do the same thing with my y equals 2 minus 2x. So I got y equals 2 minus 2x. I'd have to subtract that 2. Y minus 2 equals negative 2x. Divide by negative 2. So you're going to get negative 1/2 y plus 1 equals your x. So this graph right here is x equals negative 1/2 y plus 1. Okay, it's easy to forget to do that on these problems, especially when they give you all your equations in terms of x. But you have to if it's in terms of y. So what we're going to do to find capital R of x and lowercase r of x, you always want to start at the line that you're rotating around. So I'm going to start right here at x equals 3, and you're going to go to the furthest edge of your shaded region. That's your capital R of x. So my capital R of x, whenever you're doing horizontal lines here, you want to do right minus left. So what function do we hit on the right side? 3. And what function do we hit on the left side? Not 0. It didn't go all the way to 0. It's close. It's that purple line right there. It's negative 1/2 y plus 1. Make sure you've got parentheses there. So you need to distribute that negative. It's a little easier if you just simplify. So you got 1/2 y minus 1. And so if you put that 3 and that negative 1 together, you'll get 2 plus 1/2 y, or 1/2 y plus 2, however you want to write it. Are we okay there? Does that make sense? All right, for our inside radius. Different color. All right, we're going from the line we're rotating around to the closest edge of our region. That's our lowercase r of x. So our equation for lowercase r of x is going to be right side. What's the right side? 3. What's the left side of that function? Negative y plus 2. Make sure when you do this that you put parentheses around it, because that negative must be distributed there. So you'll get 3 plus y minus 2, which will give you 1 plus y, or y plus 1, however you want to write that. Everybody okay here? Once you have capital R and lowercase r, you are ready to write your equation. So you can write it as separate intervals, or you can write them together. If you write them as separate intervals, you'll have pi 2 plus 1/2 y squared. You will integrate that. It'll be in terms of y. What are the limits going to be? What? 0 to 2. You're looking on your y-axis right here. 0 is your lowest point of that region. 2 is your highest point of that region. Okay, so that would be your capital R of x. Then you would need to subtract the integral from 0 to 2 of pi times the inside radius, which is 1 plus y squared. We'll do that in terms of y. If it is calculator active and you just need to type it in, perfectly fine to do this. Setup problems, a lot of times they'll put these together. Or if it is free response and they ask you to set it up. This is okay unless it says something about like there's only having one integral, but they don't usually do that. So on setup problems, this is fine for the AP exam if it's free response. Because sometimes it will say set up but do not solve a integral that will give you the volume. But if it's a multiple choice question, a lot of times you'll see it look like this. You'll have pi integral from 0 to 2. And then you'll have outside radius, 2 plus 1/2 y squared minus inside radius, 1 plus y squared. Put the dy out there on the end. We are going to use the calculator for this because it's possible, but it's just very time consuming. So we are going to do pi integral from 0 to 2 of 2 plus 1/2 y to the second minus 1 plus y to the second dy, and we're getting 12.566. Okay. I think these get a little confusing, but if you will go about them very systematically. So make sure you start with a graph. Once you have that graph, think about from the line you're rotating around to the outside line, for your R of X line. You're rotating around to the inside for your lowercase r of X, and then plug it into your formula. You should be able to do these. So your assignment is here, same page that we've been working on for days now. And probably a lot of these we're going to use the calculator on as well. Let's see.
I'll scratch that.
It's not so much that any of these are that terrible to do without a calculator. But if I make you do them all without a calculator, it'll take you an hour and a half to do the assignment. So let's say that I want you to do 13D. Is that true? Actually, no. 13 is a little bit hard. Let me look at the answers. That'll help me. Let's do 15B without a calculator.
Miss Reed was supposed. I think Miss Reed was going to email whoever was in charge of it, like, hey, people are going to send them, like, I have some pictures, like, that's the thing is you can't find her, but I've got like comparison pictures that don't even have.
I gotta like, I'll have to like ask them all.
Also, like, what about this slideshow of all of us? It's just like gives like group photos of all of us.
That's what it's asking for. Those are what those pictures are. The elementary ones will go on like your own slide after your name.
That's just the
Those
photo.
pictures are for every like that's like what it's gonna be for every.
Alright, let's do these two, no calculator. And then the rest of them you can use the calculator for.
Also, an example, if you want to do the next, the corrections has